Alright, so there are two types of schemas in a dimensional data warehouse that we will discuss in this module. Star schema and Snowflake. Star schema can have one fact table and number of associated tables around it. Because its structure resembles a star, it is known as a star schema. In the following star schema example, the sales fact table is at the center, which contains keys to every dimension table to like customer ID, channel ID, date ID, and product ID, and also includes other attributes like quantity sold and amount. So in a star schema, every dimension is represented with the only one dimension table. It contains set of attributes and joined to the fact table using a foreign key. The important point in here is dimension tables are not joined to each other. That is why they do not have any foreign key column and only including the primary key fields. And also they are not normalized tables. So it means customer dimension table include both customer specific details as well as the location information, or channel table combined by both sales channel and store information. So these information stored into a single table. And when we consider the fact table would contain key fields and the measure. So in general, star schema has an easy to use structure and provides optimal disk usage. And it is widely supported by the different type of the BI tools. So on the other hand, a Snowflake schema is an extension of the star schema and it adds additional dimensions. The dimension tables are normalized which splits data into additional tables. So in the following Snowflake schema example, location and store are further normalized into an individual table. So the main benefit of a Snowflake schema is it uses smaller disk space due to less denormalized structure, and it is easier to extend the model with the new dimension tables. But on the other hand, due to multiple tables, the query performance is not as expected. So it is reduced, and the primary challenge that you may face while using the Snowflake schema is that you need to perform more maintenance efforts because of the more lookup tables. So let's do a short comparison between star schema and the Snowflake. So star schema contains a fact table surrounded by the dimension table. But on the other hand, the Snowflake surrounded by dimension table, which are in turn surrounded by different dimension tables. Star schemas has the pure denormalized dimension tables, but against this, Snowflakes can have a normalized dimension tables also. Due to denormalized structure, we have more redundant data in star schema and less redundancy in the Snowflake structure. And the queries in a star schema is more simple due to pure denormalized design, and we have complex queries in Snowflake schema due to normalized structure and additional tables. So it means in a star schema, only single join creates the relationship between fact table and dimension table, but on Snowflake schema requires many joins to fetch the data. So when we consider the performance, we will get better results in the star schema, and Snowflake schema can be relatively slow because of the more joins and normalized tables. So these are the fundamental differences between star schema and Snowflake. So thank you for your time.